Hello everyone, welcome back to my channel. This is the seventh lecture of my data science series in which I will cover the topic neural networks. This is the diagram of neural network. Neural network. What is neural network? Neural networks are computational models inspired by the human brain consisting of layers of interconnected nodes. Each neuron processes input data and passes the output to the next layer. The architecture of neural networks allows them to learn from data, making them suitable for various data science applications. Neural networks play a significant role in data science, serving as powerful tools for analyzing and interpreting complex data sets. They are particularly effective in tasks that involve large amounts of data and require the identification of intricate patterns. Components of neural network. First, neurons, the basic units that receive input, apply transformation, and produce an output. Second one is layers. First type of layers is input layer, the first layer that receives the raw data. Second layer is hidden layers, intermediate layers where the actual processing occurs. The number of hidden layers and neurons can vary based on the complexity of the problem. Third layer is output layer, the final layer that produces the output, such as class, labels, or continuous values. Third is activation functions, functions applied to the output of neuron to introduce non-linearity, enabling the network to learn complex patterns. Common activation functions include rectified linear unit, sigmoid, and TAN. Fourth is weight and bias, parameters that the network learns during training. Weights determine the strong Weight determines the strength of the connection between neurons, while bias allow the model to fit the data better. Types of neural network. The major types of neural network are as follows. First, feed-forward neural networks, the simplest type where connections do not form cycles, suitable for tasks like regression and classification. Second, convolutional neural networks, designed for processing read like data such as images. They use convolutional layers to detect patterns and features. Third, recurrent neural networks incorporate loops to maintain information over time, making them ideal for sequential data like time series or natural language. Fourth, long short term memory networks, a type of RNN that can learn long term dependencies useful for tasks like language modeling. Application of neural network. Neural networks are applied in various domains within data science, including first, image recognition. Convolutional neural networks are widely used for tasks like image classification, object detection, and facial recognition. Second, natural language processing. Recurrent neural networks and transformers are employed for tasks such as sentiment analysis, language translation, and text generation. Third, time series forecasting. Neural network can model temporal dependencies in data, making them suitable for predicting stock prices, weather patterns, and sale forecast. Fourth, anomaly detection. Neural networks can identify unusual patterns in data, which is useful in fraud detection, network security, and quality control. Fifth, recommendation systems. Neural networks can analyze user behavior and preferences to provide personalized recommendations in e-commerce and streaming services. Working of neural network. First, forward propagation. Data flows from the input layer through hidden layers to the output layer. Each neuron applies a mathematical operation to its inputs, often using an activation function to introduce nonlinearity. Second, weights and biases. Connections between neurons have weights that determine the strength of the signal. Bases are added to the weighted sum to adjust the output. Third, learning process. Neural networks learn by adjusting weights and biases based on the error of their predictions compared to the actual outcome. This is typically done using backpropagation, a method for updating weights by calculating the gradient of the loss function, which measures prediction error. Fourth, iteration and training. The forward propagation and back propagation processes are repeated for many iterations over the training dataset. During each epoch, the network learns to adjust its weights and biases to minimize the loss function. Fifth, evaluation and testing. After training, the neural network is evaluated on a separate test dataset to assess its performance. Metrics such as accuracy, precision recall, and F1 score are commonly used for classification tasks, while MSE or R squared are used for regression tasks. Sixth, deployment. Once the neural network is trained and evaluated, it can be deployed for making predictions on new, unseen data. The trained model can be integrated into applications, systems, or services to provide real time predictions or analysis. I have explained the topic neural networks. Stay tuned for further videos. Thank you.